Hey, it's Alex Williams of the New Stack. Welcome to the New Stack Makers, a podcast where we talk about application development, deployment, and management at scale. The KubeCon plus Cloud Native Con conferences gather adopters and technologists to further the education and advancement of cloud native computing. The vendor-neutral event features domain experts and key maintainers behind popular projects like Kubernetes, Prometheus, Envoy, Core DNS, Containerd, and more. Okay, here we are for another episode of the New Stack Makers here at KubeCon plus Cloud Native Con in San Diego. It's November 2019, and I'm enjoying the specter of this conversation. It's a discussion which I think is interesting. It's in looking at really how we think about the edge and how we think about Kubernetes at the edge and how we think about what we often hear as IoT. And I try to avoid that term, but I think of it more in terms of, well, we'll get to that. But first, before we get to that point, I'd like to introduce our guests. Stephen Wong is a software engineer at Cloud Native Business Unit in VMware. And Dejan Bosanac is a senior software engineer at RedHat. He's a member of the Apache Software Foundation and committer at the Eclipse Foundation. I set this topic as it's not a car, it's a node, Kubernetes at the edge. And I'm fascinated by this idea of, how everything we think of as, something real is actually something made of something else in many ways. It constitutes many kind of different composition of many different types of things. And so we could actually classify it and label it as something that's other than what we think of it as, like a table or a car, whatever it might be. And one of the fascinations to me has always been about distributed computing is how we now have all this compute, storage, networking capability for applications, but they're mostly focused inside of a data center, or even in a cloud is really kind of a combination of multiples of data centers. And as we discuss cloud native technologies in Kubernetes, we've started to migrate towards this discussion about what is the context of the world beyond the data center, and how do we bring the clusters to those places out at the edge where the objects then need to be thought of much differently than just connecting to a computer or a smartwatch or even a phone. So how has Kubernetes entered this discussion? How have cloud native technologies entered this discussion?
Well, I think one way to look at edge, you first define it, and your car analogy is spot on, because there's two aspects of it. A lot of the luxury models of cars now have as many as 37 computers inside them. Now, they might be tiny computers, but you've got things like the entertainment system, the antilock brakes, the traction control, even the power doors and windows often have a little controller associated with the motors that drive those. Now, when you say these are objects, there's two things that you need to do with these objects. One, they're sources of data potentially that somebody somewhere in the world would like to know. Number two, they often need configuration and updates. And, Kubernetes originally was developed as a system using a control plane to control vast numbers of containerized applications in a public cloud under circumstances where you didn't want humans doing that with their hands on, you did it remotely. But the architects of Kubernetes started by building a foundation for this rich and, as it turns out, extensible API that can control things at massive scale through an API where you state the desired outcome, that I want these things to be in this condition in the perfect world. And then things called controllers work in the background to relentlessly drive the state of the real world. They take note of what you said you wanted, measure what this thing is now, and relentlessly drive it towards your stated goal. And they don't do it with just one loop. They enabled it so it was parallelizable, so you could have thousands of these things working simultaneously, driving the world to this. Because it was extensible, it means that it's not necessarily confined to controlling containerized applications. 2 years ago, I found on YouTube, preparing for a talk I'm giving here, a slide deck where somebody used the exact use case of a temperature sensor, declaring whether you wanted this temperature sensor to measure in degrees Fahrenheit or Celsius, and I think it was just to prove a point simply that, this is how you do one of these custom resource definitions. But Kubernetes has the potential to be a toolkit to automate managing these things out there at edge. And by the way, it isn't just consumer objects, it's potentially a lot of the people, Dejan and I represent a working group within Kubernetes. A fair amount of the people who come there are trying to do remote office, retail stores, fast food retail outlets, things like that, and kind of control a little shop that is by no means a data center. It doesn't have racks of computers.
Yeah.
But that also comes under here.
Dejan, isn't that the first front, really, those industrial objects? And perhaps maybe you could give some context for Kubernetes and maybe even the shortcomings that need to be addressed to be able to make these a reality.
Just to extend on the Steve's points, so Kubernetes is there, but I think cloud native is really a key enabler in all this edge computing. So we'll talk maybe a little bit later about hypes and everything, and I think everything will be labeled edge at some point. But I think, so it's nothing new. People try to put compute resources on, distributed for a long time, for decades, right?
Right.
But what changes now, and it's the same thing like when we had a transition from machine to machine, and suddenly everything was calling IoT, right? So now every of those systems will try to label themselves as edge. But to me, edge is really just an extension of the cloud. So we need a cloud-native architecture on the backend Kubernetes, but we need also all the tools for developers that they use to build applications that can run only in cloud to be able to deploy it on these edge sites as well. So it's a whole, so to say, continuum of platform and developers tools that will enable to do these things on a massive scale that people want to do.
And doesn't this get into kind of your space that you are an expert in, I would assume to say, in terms of connectivity and messaging?
Yeah.
And that's a lot of your work at the Eclipse Foundation, isn't it?
Yeah. So at the Eclipse Foundation, for the last couple of years, we try to build a basic fundamentals for a cloud IoT cloud platform that will be open source and based on open standards, and that's going pretty well. But even with that, we see that things are changing. So for example, even if you have a very good connectivity platform for the cloud, right? We can support today millions of devices connecting to the platform, but it's just getting more and more. And the solution, and one of the things that edge computing is trying to solve is to bring those compute resources closer to the source, to the things, to the devices, instead of all of them connecting to the central cloud. So what we want to do next is exactly that. So try to re-architect that on the good concepts that we have today, and try to distribute this architecture so that we can have a local connectivity for the devices, maybe some local processing there, so saving the bandwidth, improving the latency, all of these things that we usually talk about in the context of edge computing.
If I can step in, I can give an example. I agree with Dejan that, for example, take an example of edge devices being security cameras that are maybe collecting 30 or more frames per second of video. You don't really want to upload all of that video to the cloud if what you're really interested in is collecting license plate numbers or the names of the people who walked in a door. So there's a use case where that data, the frame by frame videos coming from that camera, has a gravity that would like to pull processing towards it, machine learning, image recognition and tagging, out towards where the data was collected, because there's less that can go wrong, there's lower latency, and you get your results sooner, and frankly you save bandwidth. You didn't have to send the massive amount of information up to the cloud if you could process it and greatly reduce it by 3 orders of magnitude by reducing it out at the edge. And there's ultimately, those things, those machine learning apps and things that are associated with these sensors really are containerized apps like Kubernetes is used to managing. In a way, you could argue that edge computing really is cloud computing. You've just inverted the place where these containerized apps are going to run. Now, it does help if you can integrate management of dispatching those containers, running them, monitoring their health, with managing of the sensors and the actuators out there at the edge, along with managing the network interconnects. Yeah. And I'm not saying Kubernetes fully has this down, but that's the point of our working group, to get discussions going, to do a barn grazing.
How does the container...
It's the best foundation we have today, and we should build on top of that to provide a better experience in the future.
How's the container technology going to have to adapt to that? These are, if we're talking about edge, let's just, talking about industrial environment, for example. Are these containers the same containers that are running in a data center that are running out at the edge? Are they smaller in size? Are they lighter weight? What are the kind of considerations?
Yeah, there are a couple of things that people should be aware of. I think resource constraint is always a big concern, because one thing that you don't have on the edge is auto-scaling, which is a big promise of the cloud computing, right? You need more resources, you click a couple of buttons, put your credit card, and problem solved. On the site, you have probably a limited number of nodes, and it's very expensive to get additional resources there. So developers need to be more careful about how they write those applications. Yeah. Some services need to be critical, higher priority. Some services are, a less priority, could be evicted. So those are some of the concerns. But in the end, we have those tools. So those containers applications should be able to run in the same way in the cloud or in the edge. It's just a deployment option that should take some consideration if you're thinking of putting them there.
A couple things that maybe are different. Dejan's point is valid that, frankly, even in a big public cloud, people do the wrong thing and take a VM and literally move it into a container, and it's this 1 terabyte container, and that's always a mistake, but you can cheat if you're willing to pay for it in a public cloud, and it flat out blows up if you try to do that at edge. So you got to do it the right way. But
it blows up. What do you mean? What happens?
Well, you just don't have rack after rack of computers. So you have a finite amount, and when it runs out, it just doesn't run. If you demand this monstrous amount in AWS, your bill goes up, but it runs. You just pay a lot of money for it. It just doesn't run out at edge because there's nothing to back it up.
But why not? Okay, so let me play devil's advocate then. Why not a micro VM then instead of?
Well, no, it isn't even just the money thing. It's often the physical size, even the nature of processors. One difference in the containers are that I think there's a bigger demand out at edge for things like ARM containers. A standard Docker container image is actually CPU specific. And it's not even because the CPUs are cheaper, but you've got situations where you don't have air conditioning, and you maybe are constrained to a small physical size if you're building a traffic light controller or something. Right. And you just picture them as they're running on something more akin to a cell phone than a rack mount server.
Yeah. And I think one more thing to answer that question is developer, because they want to have a seamless. I think if we're going to do edge successfully, we need to attract developers, and all developers are now in the cloud native, and they want to use the same tools and same practices they use today to develop those applications. And in my mind, it should be like that. Like, you should be able to write your microservices as you write them, right? And then you can deploy them wherever you want. Should it be like a cloud-only deployment, or should you be able to move some of the microservices closer to on some nodes or some clusters closer to the devices and the data? That's what cloud native computing gives us, and that's why we need Kubernetes and all these things we have today to be able to do that tomorrow.
Go ahead.
I'll tell you another aspect you need to keep in mind that's kind of the next layer above the container runtime and the container images themselves, and that is the registry it comes from. typically people architect these apps in a public cloud to pull the images out of, say, Docker Hub or something, and it's essentially guaranteed you can get there from here when it's running in a public cloud. But a lot of these edge applications have very intermittent connectivity to the internet. The bandwidth that's there can go from 0 to poor and never to good. And it means that you have this consideration in many of these where you want to build up a cache or an image registry on premises so that you're pre-populating and pulling it from there. Let me give you an example of a retail store suffers a power outage, all the computers reboot, and they come up and the internet connection is lost. Or it's so poor that if every computer in a big retail store goes and tries to pull images at once, it's sucking it through a little soda straw, and it's just going to take hours. And none of the cache registers in the store can come out. That would be bad. So you need a solution that caches that kind of stuff. And there's even some, like I've heard of cruise ship lines and things that are actually using containers, and they only dock in port once every few days, but they can get it to work properly if you properly design.
Yeah, there's restaurant
caching.
chains who are using clusters inside the actual stores themselves. Mike, I want to get back to what you bring up too, is this intermittency issue, and that gets back to the connectivity issue and the messaging issue. And I know you've been working on some projects, in particular, event-driven messaging and ActiveMQ Artemis, for example. And how is this architecture better suited, to these new types of environments?
So there's a lot of I think messaging in general in IoT is a basic communication pattern between, because that's the normal way of how things communicate, sending messages back and forth, right? So what we've done so far is trying to, for example, in a couple of these projects, try to put some more semantics on top of those communication that's going on. So trying to narrow it down basically, because general messaging is too broad and people reinvent every time and make silo applications because everybody's solving the same problem in a different way. So we try to do a little bit more to constrain them in terms of, in IoT and in these kind of environments, you have two basic semantics. So sending some kind of telemetry from the edge to the cloud and sending commands back to devices. So we try to create a couple of APIs that should allow people to more easily reuse them and create something that's interchangeable and integratable instead of everybody solving their own problem on their own. But another thing, as you said, is what we're doing right now is trying to do a technology that we coined so far as a virtual application networking, and that's kind of trying to solve these multi-cluster or hybrid cloud communication in a better way. And that problem is particularly visible in the edge scenario, where you have a lot of all these edge sites are usually in the private networks, not reachable from the outside world. So we want to make sure that our services running on the edge and on the cloud can communicate in a duplex way. We want to connect two services running in two different private clouds. So what we did is try to apply networking principles on the layer 7, completely on the application layer. So that mitigates a lot of problems in trying to set up VPNs, firewalls, and all that kind of things manually. So that's one of the ways.
So the layer 7, because this gets into like the autonomous networks versus networks that are, that traditionally that we know that might be running in a data center and calling out to a node, for example. And now the nodes may necessarily have to communicate with each other, right?
Right. I think it's fair to say that in the bulk of these, most of the traffic by volume is leaf node to leaf node. And you really don't want one leaf node hairpinning up to a public cloud and coming back, because it's not
For
resilient.
people who are not really familiar with what is a leaf node.
Well, if you've got an edge, picture it like a tree where you, say, branch from the central public cloud. out to the branches, and
Right.
at the tips are leaves. And you might have 100,000 leaves. And I'm saying that in many of these applications, a lot of these leaves want to communicate with something nearby, some other sensor nearby, like a motor is triggered, needs to talk to a sensor to decide when to turn on. And they're at the same physical location in the same city, in the same block, but you don't want the sensor signal to go way up to a cloud in Seattle, then, from Pittsburgh, then come back down to the motor in Pittsburgh. That's just not going to work out well for you for a lot of reasons. So
Right.
that's what I mean by leaf to leaf. So you want some sort of networking facility where maybe a central control plane is desirable, but it needs to keep out of the data plane so that you don't inject latency and you don't have an unnecessarily long path. Security is also a big issue here, like when he raised the issue of L7, and typically up at L7 HTTPS, people use things like TLS certificates, and some aspects of that don't necessarily work well at edge because really when you look at these certificates, they get installed in a device that you presume you have physical security over. Somebody can't go there and steal it. But with a lot of these edge devices, if somebody was to grab the device and the certificate with it, and that gave them a ticket onto an internal corporate network, that is really bad. I hear rumors that there have been people burned by not thinking of these aspects of their design, but by going to specialized protocols designed and incapable of getting generally routable around the world, they might actually be that might actually be a feature rather than a deficit, because they'd be incapable of getting to places generally you don't want them to be capable of. Some of this actually, it's interesting, like Dejan brought up MQTT, and arguably one of the hottest things here at KubeCon is this idea of service mesh, Envoy proxies, where the idea is that the average app developer isn't a networking expert or a security expert, and if they don't know it well, they're going to make mistakes and you suffer. Really, I would contend that that old MQTT that's been around a while was, whether they knew it or not or called it that at the time, did that same thing of throwing, relieving the app developer of needing to know networking. It's a publish subscribe thing where when you want to publish this sensor information, you just give it a label. You don't have to keep track of how many people are subscribing. That's kicked off on the underlying communication platform.
Another abstraction.
And some of these tools actually were very well done and are very close to what feels like new things like Istio and Envoy up in this data center world. But they're also close enough that I think a lot of these concepts of service mesh and a central control plane maybe can backfill and put a facade layer on this kind of legacy stuff in the IoT space and deliver great value.
Then it gets into the next generation of connectivity and messaging, doesn't it? And because some of the concepts I've heard about is that we have these compute storage and networking capabilities in these massive data centers now. The compute almost sometimes seems endless, and the networking capabilities are what we never possibly could be dreamed of, that we never could have dreamed of, and there's storage is just an afterthought almost, right? So there's these vast resources that are available in these these hyper data center environments, and what is then going to be? I mean, one of the questions I have, I guess, is as Kubernetes architectures evolve for developers and building out applications for phones and for still computers or whatever, how do we think about how the data center will evolve? Because one of this is where one of the kind of the concepts I think is interesting about functions, right? And how the role of functions and what role functions will play in helping kind of deliver almost intelligence out to these nodes, so then the nodes can then communicate with each other based upon that the intelligence that's being sent to them.
So one of the things we're trying to solve with this is, which maybe can help here, is if we move the service discovery and adjustability to the layer 7, we get much more flexibility of where our services live, and as you said, like in like a publish-subscribe kind of manner, we can layer on top of that much more complex messaging protocols than it's a simple load balancing and request reply that we have with HTTP and DNS as the solutions in the service meshes. So there's a lot of lot of things that could be done to mitigate those kind of issues. And then when you have this adjustability solved, then you can do what you're saying, moving functions, moving services all around, and making these distributed data centers. One important aspect there is that so we've been talking so far about the edge from the IoT perspective and retail perspective, but there's another big group of people interested in these, and these are the service providers, telcos, CDNs,
Telcos.
ISPs. But they look at the edge from the completely different angle. They see their own point of presence kind of infrastructure that already exists, and say, why don't we use that to host some of these services and things like that? But they don't have these constraints. They can put
They just can put it out.
Yeah.
Yeah.
The telcos are showing up to our working group meetings in huge numbers. I think maybe it might be literally all of them in the world. I mean, I've certainly seen all of them I know of showing up to the meetings.
That's fascinating.
And it's not a concept of, if you have this dream of how does the data center, and you're picturing something like the AWS cloud or the Azure cloud or the Google cloud, how does it change? I think what changes is there's more clouds hosted out towards edge locations. What if you envisioned a world that the data gravity pulls demand for hosting things not in a couple or a handful of places in the world, but in every major city of over 200,000 people? And I think really that's what's going to happen and change, that you're going to have a lot more data centers. Now, there's no reason they can't be powered and managed by Kubernetes, but picture a world where there's more of them. And it's not just me saying this. I think I encountered an analyst forecast saying that by 2022, 70% of the processing workloads that process data generated at the edge will actually be running at the edge. And it was predicting that even though we've had this hockey stick growth of new workloads being deployed to these big central public clouds for the past 5 years, that we're about to enter a world, and LTE 5 is a big enabler of this, of big deployments out at edge locations. Now, the telcos sometimes have the ability to host multi-tenant clouds out at edge locations.
But the question is, what will the developers want to do? So I think that's going to be the biggest question, is because they have those. They also had the dial tone. They also had the infrastructure for the internet. But we know what happened. I mean,
well, you use the old dial tone analogy, which is interesting, and it's a throwback. I'm old enough to remember that. I don't know if Dejan is, but one of the concepts is that in the 90s, when the world moved from dial-up modem to broadband, it was a big bandwidth improvement. But the real thing that disrupted society was the fact you were always on. I mean, I remember when you went through your household saying, does anybody need to make a phone call, or does anyone expect one? And it goes off the air. And once you were always connected, it rapidly changed to every member of the family has their own device, or a couple, and you expect them to be always on. Well, LT5 is like that, where it actually is going to be a big enabler of, say, 3 orders of magnitude more devices, and its modeling of connections makes it economically viable to have some really cheap device that just squirts out a signal saying this light switch switched, and it only has to send it once every 2 weeks, and you don't have to pay for a data account on a monthly basis.
we're going to have to finish up here in a minute. So, John, I would like to just get from you, and then Steve, maybe you could conclude. What are the projects you're working on now? What is the conversation you're having here at KubeCon? What is it following KubeCon that's on the horizon?
Yeah. So Steve and I represent the Kubernetes IoT Edge working group here, and we're trying to build a community of people interested in in general this topic. And as you see from this conversation, the topic is so huge and,
Yeah.
and so wide that you can attack it from any angle.
Yeah.
And so far we're having really good discussions, but everywhere you look, you scratch a little bit and then you open a completely new field. So being the networking, being the developer tooling and things like that. So me particularly, I'm continuing working mostly in the connectivity. So working for the IoT connectivity and working on this Scupper project, virtual application networks, that we try to enable distributing this connectivity closer to the edge and making a better experience for this edge world in terms of messaging and networking. So that's mostly been my focus going on. And what also, sorry, Steve, would like to do, and what I'll talk about today, mostly so far we were talking about infrastructure, about platform, how to get Kubernetes there. We still don't talk much about developers, and I think that's a very important topic. So,
Yeah.
so I would like to encourage people to start taking those discussions more seriously. How
do we set up those playgrounds for them? Or, those
how we use
spaces?
GitOps on the edge, how we use all this kind of stuff in this new environment.
So I'm here more not to represent my company, but to represent the IoT Edge Working Group. And I guess my campaign is to facilitate the whole community doing this. And we're going to have to probably ramp from one topic to another. We just finished a security white paper. I think we're talking at KubeCon this time about something to coalesce the unique protocols and communication protocols found out at Edge. One of the things that I'm campaigning is this idea of actually extending the Kubernetes control plane through CRDs to put a facade on legacy stuff. One of the issues with this whole space for industrial IoT in particular is that people buy that kind of stuff on 20 to 30 year life cycles. They don't replace it like a rack mount server in a data center probably has a lifetime of 3 to 5 years and you change it out. So if you had to rip and replace all your existing legacy, that's not a great solution. A lot of that stuff has been out there and uses proprietary APIs, unique to one vendor communication gateways, but I think there's a real opportunity to go put a Kubernetes control plane and data collection mechanism on top of that stuff and enable the end users of these things to do new things without ripping out all of the old stuff. I think that's really a key lesson to be learned even with containerization in Kubernetes, that there's greenfield apps, but the real big value thing is when you can bridge greenfield with legacy and get the whole thing to work, because nobody does a big bang replacement of the entire world at once.
Well, thank you very much to the two of you for joining us today.
Thank you.
It's been a conversation I look forward to continuing. I'm sure this is just the start of these conversations on how we think about the world beyond the data center into these environments where we're looking at, how we think about networking, how we think about, these developer spaces that can be created, and how we think about these other issues like you're talking about in terms of, how we think about containers in these environments and such. So thank you very much. Steve Wong, software engineer, Cloud Native Business Unit, VMware, and Dejan Bosanac, senior software engineer, RedHat, member of the Apache Software Foundation, and a committer at the Eclipse Foundation. Thank you both for your time.
Thank you, Alex.
Thank you.
The KubeCon plus Cloud Native Con conferences gather adopters and technologists to further the education and advancement of cloud native computing. The vendor-neutral event features domain experts and key maintainers behind popular projects like Kubernetes, Prometheus, Envoy, Core DNS, Containerd, and more. Listen to more episodes of the New Stack Makers at thenewstack.io/podcasts. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.